Hello, students. Okay, I'm going to go briefly over what is important about the one-way ANOVA. So this is what you need to know about the one-way ANOVA. ANOVA stands for Analysis of Variance. It's always about the variance from now on. Variance. That's what advanced statistics deals with. Variance is your goal. Okay, so for a one-way ANOVA, all it does is it compares the means from three or more groups to see if they're significantly different from each other. All one-way ANOVAs have one DV, dependent variable. That's what we call a univariate. If it had more than one DV, then it would be called a multivariate. Okay, but univariate means one DV. And that DV has to be continuous, also known as a metric, ratio, scale, any other numerical names you want to call it. But it has to be a regular counting number. In other words, where 5 is greater than 2. Okay, that's what your DV has to be. It cannot be categorical, not for an ANOVA. And it has one IV, which has to be a categorical IV, or nominal, discrete. It goes by many, many names, but it's any kind of variable that puts the subjects into separate categories. So your IV has to be a category type variable. Your DV has to be a regular scaled variable, okay? And you need at least 3 levels of your categorical IV. In other words, your IV needs to have at least 3 separate categories. Sometimes they're called subgroups, but levels is normally what we go by. So an IV with 5 levels, right, is still one IV, but that just means it has 5 subgroups, okay? So get good at that. If you have 2 IVs, that's what we call a two-way ANOVA. If you had 5 IVs, that's what we would call a 5-way ANOVA. So one-way ANOVA has one DV, one IV, right? One categorical variable, one dependent variable. If you have 2 DVs or more, that's what we would call a one-way MANOVA. The M stands for multiple analysis of variance, okay? But we're not going to be doing that anytime soon. So back to our one IV, one DV, one-way ANOVA. You got to know the assumptions. The data has to be from random sampling, and that's not just the ANOVA, that is everybody, right? You can't play favorites. You can't pick the ones you want. You have to be random in your selection. Your data has to be normal. It has to be independent of observation. What that means is one subject cannot influence another subject in your study. And the last one is homogeneity of variance, which means that your levels of your IV have to be relatively the same, and your DV relatively the same. So there's a couple of types of designs here. The main one is the between groups ANOVA, and that's where each subject is in one and only one level or subgroup. The other one is a within group ANOVA. All subjects are in the same level. Okay, there's just one big group, and everybody receives every treatment or condition, etc., etc. So that's a within group. Within group ANOVAs are also called repeated measures ANOVA. You guys didn't do those. Okay, so this is how you do an ANOVA. You're going to take your source of variance table. It's on the website. You're going to go ahead and turn these little squares into actual numbers, okay? You're going to do the calculations from this table. You will calculate your significance, your effect size, and your power. You can get all of that stuff from this table. So I'll say that again. The 3 things you're going to look for in any ANOVA is your significance, effect size, and power. Significance, significance, significance. Significance is your F test. Your effect size, you can take it right from the table, from your source table. It's just the sum of squares between groups divided by the sum of square total. That is your effect size. And power can get kind of ugly. So there's the formula for power. And I don't think I'm going to make you guys calculate it by hand. But if you want to, there's a video on it. But this is what you got to remember, that power is strongly related to sample size and effect size, okay? In other words, when sample size goes up, your power goes up. And that goes back to the law of large numbers, which basically says the more data you have, the better it is. So that's the main things that I expect you guys to learn this week. So that's it. MGZ out.